Good morning, everyone. My name is Jekaterina Ivanova, and I am from Latvian Institute of Organic Synthesis. And the topic of my talk is synthesis and biological evaluation of novel thyroidoxine reductase inhibitors as anti-cancer agents. In recent years, thyroidoxine system has been repeatedly reported as a promising target for the development of anti-cancer agents due to its ability to regulate the cellular redox homeostasis. Elevated reactive oxygen species and antioxidant defense systems have been recognized as one of the hallmarks of cancer cells. Reactive oxygen species are side products of enzymatic reactions, and in cancer cells there is higher level of reactive oxygen species than in normal cells due to uncontrolled proliferation and fast metabolism. High level of reactive oxygen species makes cells vulnerable to oxidative stress. But thyroidoxine reductases, which are the only enzymes that reduce thyroidoxine from its oxidized form to reduced one, they scavenge excessive reactive oxygen species. Thyroidoxine reductase has three isoforms. The first and second ones have comparable properties, but the second one is present in cytoplasm and nucleus, but the second one is mitochondrial. Thyroidoxine reductase third isoform is less abundant and localized in nucleus as well. Due to the increase of oxidative stress linked to cancer progression, the first isoform of thyroidoxine reductase is known to be overexpressed in various types of cancer compared to non-cancerous tissues. So it makes it possible target for cancer therapy. And thus, targeting thyroidoxine reductase 1 is promising therapeutic strategy due to the vulnerability of cancer cells towards the imbalance of reactive oxygen species. Most of the known potent inhibitors of the thyroidoxine system have an electron-poor site, and they are considered as characterized as electrophiles. Mammalian thyroidoxine reductase 1 has a selenocysteine residue, which is located on the surface of the enzyme and is highly nucleophilic. So it's possible that inhibitor, which is electrophile, makes a covalent bond between enzyme and these inhibitor molecules. The covalent bond is formed, thus inhibiting the activity of enzyme. And such electrophilic molecules comprise a pharmacologically important group of thyroidoxine reductase 1 inhibitors, and they are classified as Michael acceptors. And in this work, we describe the derivatives of barbituric acid and Meldrum's acid, as they also have a Michael acceptor moiety, this one, although they also have a carbonyl group on the other side of the double bond. So we decided to check if these compounds also serve as thyroidoxine reductase inhibitors. So here you can see the synthesis of barbituric acid derivatives. This is a simple reaction between barbituric acids and various aldehydes. So we got here 12 derivatives with high yields, and in the table you can see the thyroidoxine reductase inhibition data. All the compounds were screened at 200 micromole concentrations, and here in percent you can see the inhibition. Most of the obtained compounds have inhibited the enzyme, and the most promising ones are 2G and 2H, these ones. And so for them, we also determined the inhibition activity at lower concentrations. And also, it was possible to determine IC50. Here you can see the data. And then we checked also Meldrum's acid derivatives. Also, we took Meldrum acid and here is its reaction with various aldehydes. We got 8 derivatives and also checked the inhibition at 200 at the concentration 200 micromoles. And yeah, here you can see the inhibition data. Unfortunately, these derivatives didn't express as high activity as previous derivatives, barbituric acid, so it was impossible to determine. Actually, they didn't express any activity at lower concentrations, so it was impossible to determine IC50. And to conclude, I can say that a series of barbituric acids and Meldrum's acids were successfully synthesized, and most of obtained compounds show good inhibition of cancer-associated enzyme TrxR reductase, first isoform. But barbituric acid derivatives show a bit more, seems to be more promising tyrosine reductase inhibitors, and as Meldrum's acid derivatives, then Meldrum's acid derivatives and some of barbituric acid derivatives express reductase inhibitor activity also at concentrations lower than 200 micromoles. I would like to express my gratitude to Recovery and Resilience Facility, my postdoctoral grant, and thank you for your attention.